I am Steve Lorello. Like Matt said, I left Vonage about a year ago. I am old Matt, but I am the .NET developer advocate at Redis. And today I'm going to be unmasking Bitwise operations with Redis. So Bitwise operations are something that is in just about every programming language, but I think a lot of modern web developers have never really looked at before because they don't necessarily need to use them. But so what are Bitwise operations? Bitwise operations are operations that you perform on strings of bits. You either perform them on multiple strings of bits or single strings of bits. They encompass a bunch of different, there's a bunch of them. You usually like see them with different like kinds of gates and stuff like that. But essentially they're like ands, ors, XORs, nots. And then there's usually like shift operations. So like an and, if you have two strings of bits like 1110 and 1011 that we have here, and you and them together, you go through each bit in the string and you compare them. And you see for and, if 1 and 1, so if they're both 1, they come out 1. If one is 1 and the other one's 0, it comes out 0. And if either of the bits are 0, it comes out 0. For ors, it's the same way, it's the same thing, but instead of 1 and 1, it has to be 1 or 1. Just like these are just normal like logical operations. For XORs, it's exactly 1 when you're comparing two-bit strings. For knots, you just take the bit string and you produce the complement of it. So 1100 not is 0011. And then shifts are where they get actually really interesting. I actually really like shifts. And the first job I ever did using .NET, we were doing a lot of like low-level signal processing, and we ended up using a lot of shifts. But essentially, you take the bits and you shift them over to the left, to the right by the operand over here. So essentially, when you take 1 and you shift it to the left by 2, you wind up with 100, which of course this is binary, so 100 is actually 4. And the reverse, when you take 100 and you shift it over to the right by 2, you end up with 1 because this is all binary, right? So that's just a basic explanation of bitwise operations. Now, bitwise operations in Redis, so people are probably generally aware of what Redis is. Redis is a NoSQL database. People use it pretty extensively for caching, and it has a ton of different commands. And a couple of those commands actually fall under the bitwise operations Bitfield command group. So bitwise operations in Redis can essentially be accomplished through a combination of these two commands, bitop and bitfield. So bitop allows you to do ands, ors, XORs, and nots. Bitfields essentially allow you to build customized maps of bits, and they can effectively be used for doing the kinds of left and right shifts that you would normally do in your bitwise code. So why would you use bit operations though with Redis? Let's take an example. And oftentimes when we're doing like telemetry things, like you are shipping maps of bit data. So let's just look at a very simple piece of telemetry. Say we have a little instrument that's traveling around the world, and we want to like see where it is in time. So we want to have a longitude, latitude, and an instrument ID. That we're going to constantly be streaming telemetry back to like some centralized spot, right? So the naive way that you might store this is by storing the longitude as a field in a hash, the latitude as a field in a hash, an instrument ID as a field in a hash. But the problem is that this is going to create it's not like a super heavyweight, but it's somewhat of a heavyweight object in Redis or whatever database that you're using, because all of these numbers that you're getting are usually like floating point numbers for longitude and latitude. And the instrument ID, maybe you're defining it as a single byte thing, or maybe it's a relatively large number that you're storing, or maybe it's a string that you're storing. But basically, best case scenario, you're probably looking at about 96 bits of data. Most likely it's even larger than that because the longitude and latitude you're going to be shipping to it are probably going to be like floating point numbers when they don't necessarily need to be. So let's look at like how we could actually store this using like a bitfield or a bitmap. So let's say that we're going to take that 96 at a minimum bit of telemetry and squash it into 60 bits. So we could build this this fun little data structure here that's 0 to 20, bit 0 to 25 is the longitude, bits 26 to 51 of the latitude, and bits 52 to 59 of the instrument ID. So what this means is that the latitude and longitude have gone from being, we need to enforce this as a, strictly floating point number to, longitude really only goes up to longitude and latitude only go up to 360 and 180, right? Or negative 180 to plus 180. I forget exactly what it is, but basically you don't need more than 26 bits to store all the information for a longitude and latitudinal point in a number. So you could take them and you can convert them to 26-bit fixed point numbers. So 1 bit for the sign of the longitude or latitude, so plus or minus, and then 9 bits for the integer, the integral portion of it, and then another 16 bits for the decimal. And you just fix a point where you're going to actually store the decimal, right? And then for instrument IDs, like in this case, we're just going to use an 8-bit number. So this is what our actual bit map looks like. So 0 to 9 is the longitudinal int, 10 to 25 is the longitudinal decimal, and so on and so forth. So how would we actually set this in Redis? So in Redis, you would basically, let's start off with a particular point. So longitude is negative 122.0641, latitude 37.3772. ID is 5. I forget exactly where this is, but this might be near me. I forget exactly where on the map this was. So let's take that longitudinal point, and we can go into a Bitfield. So we can use the Bitfield command and set a key in Redis. So in this case, we're setting the telemetry key, but you would ordinarily switch around what the key name is. So Bitfield telemetry set, and then we can define the actual encoding of the number that we're passing in. So in this case, like we're doing for the integral portion, it's 10 bits, right? So we're doing an I10. An I10 is a signed 10-bit integer. We go to the offset of bit 0, and we pass in negative 122, which was the integral portion of this. Then we can take this same bit field and set a U16. So this is now an unsigned 16-bit integer at offset 10, 641. So now we've actually stored this negative 122.0641 in this telemetry data. And you do the same thing for latitudinal data. And then except instead of going to 0 and 10, you now actually have to offset into the telemetry bit by 26 and 36 to actually set the appropriate parts of the bit field. And then with when you're setting an instrument ID, you just go to bit 52, which is 26 times 2, which is the size of our latitude and longitude. Go all the way to the end, and you would just set the value of 5. And so you've actually set it now in Redis. So then you can query those different parts of the number directly with the bit field get. So for the integral, we would just go in and say, for integral for longitude, you just go in and say bit field telemetry get I10 0. So starting at offset 0, we're going to pull back we've defined that, we want to have a 10-bit signed integer. We're going to pull back whatever's in there. Same thing for the decimal, but you're going to offset 10. You're using an unsigned 16-bit integer. Same thing for latitude, but again, you're going to 26 and 36. And then for the ID, you're getting a unsigned 8-bit integer from starting at 52. And that brings us to masks. So what are masks? And masks are something that I think a lot of developers aren't necessarily super familiar with because many of them never had to use them before. But they're essentially strings of bits that allow you to highlight substrings of bits within a larger string of bits. And they're often used as like the right-hand operand in bit operations. So if we're taking this telemetry data, we're going to mask something against it using one of the bit operations, and we're going to output something, right? So let's look at building a mask here. So we have 60 bits of telemetry data. Our longitude is bit 0 to 25. So the mask for our longitude would be this whole number right here, right? So this is 26 bits of ones followed by 24 bits or 34 bits of zeros. This comes out hexadecimally to this string right here, and then the decimal is this right here. Same thing with latitude, except you're dropping 26 bits off of here because that's the longitude no longer being really looked at here. That's this represented in hexadecimal, decimal. And then for the instrument ID, it's just FF because it's the last 8 bits of the bit field. And to actually perform these bit operations, you would just say bit field longitude, Unmask here, set. You're building a U60, you're starting at offset 0, and you're passing in this huge long number, right? Same thing for the latitudinal mask, except it's that smaller decimal number, and the same thing for that ID mask, except passing in 255. I think if I was writing this into code, I would probably use hexadecimal because it's a little more obvious and it's a little cleaner. But this is just like these are just meant to work directly in the Redis CLI. Then you basically set. So like in this case, let's say we want to have like a current longitude, current latitude, and current ID. You basically pass in that bit operation, and then you pass in, you would use bit op, you would pass in the operation, which in this case is going to be and you're going to store the output of this operation in current lon, and then you're going to take that telemetry data and you're going to mask that longitudinal mask against it. Same thing with the latitude, same thing with the ID, all very similar things. And then you can just query them directly by using basically get current lon. You just go in and you pull back a 26-bit number from position 1. So when you use the hash sign ahead of the offset, that's basically saying I'm offsetting X number of whatever the encoding is into the bit field. Same thing. So same thing here. And then we're pulling back a U8 at bit position 52. So that's about it. That's all I've got about bit operations. If you want to learn more about Redis, just check out Redis University. There's actually a whole section in one of the classes we have there about bit operations. And the more you can learn a lot more about bit operations at redis.io. So I think it's time for me to pass off to Scott. I'm actually really looking forward to his talk.